morning, guys, or should I say afternoon?
Afternoon, ma'am.
Chickens with exponents. And as I say, there were a lot of examples in the textbook. And what I will do is, when I finish the lesson, I will go to the teacher's guide, if I can find it, and send you the memo. The main thing, even if I make this up, I just want to make sure you understand the difference between the type 2 and the type 3. So I'll just quickly do one more of each, and then I'm going to move on. So for those who maybe did number F, 2F, sorry, not F. I want to do a type 2. For those, okay, let's choose one that, let's just say you've got simplify,
Yes.
no calculator, and then you notice that your bases are all joined together by multiplication and division. All right. So lamb chops, that is type 2. Do you remember what is the thing you need to do when you see a type 2? You look at it, what's your aim? You can remember the aim. What is my aim? I'll give you a clue. You want to break something into something. What?
You break it into common factors, like break
So
six
break
into
the bases into
break
prime.
6 into
Prime
3.
Okay. Prime numbers, prime factors. So 6, do we agree, is 2 times 3?
3.
Okay, but 1 in a bracket, raise the exponent of x plus 1 times, well, 2 is prime, so it's just 2 to the exponent of x minus 1 divided by 4. You can make 2 squared, but you're raising the base 4 to the exponent of x is 2, so base 3, so 4. Remember, a lot of you would have gone, so you've got your base times the goes to 1 by both of the exponents. You get x plus 1 times, then you get that 3 to the x plus 1, then you get times, just keep the 2, don't break that up. You've got 2 to the x minus 1. Sorry, not much space left in the denominator. Now watch, you've got the base 2. Do you see that becomes a 2x? And then times, and then there is your base 3 to the x minus 1. Okay, I need to borrow a bit of space here, so just let me just equals. Now you only have bases 2s and bases 3s. So write your base 2, any exponent in the numerator, add. Because same bases multiply, you add the exponents. So x plus x would give me 2x, and plus 1 added to minus 1 is 0. But do you see the 2 base in the denominator? Now in the denominator, the exponent is plus 2x. So you bring it up with the opposite sign, because my aim is to bring everything from the bottom up to the numerator. And I can do that if everything is 5. Now let's look at the base 3. So just write base 3. Now, in the numerator, you have a plus x plus 1. Do you see in the denominator, the exponent is also plus, but minus 1. So remember, when you bring this base to the numerator, you swap the sign of the exponents. So it's going to be minus x. See that plus x became minus x? That minus 1 becomes plus 1. by doing that, then there is a ghost 1 in the denominator. There is nothing left that you can visually see. Now let's look at the base 2. Do you agree 2x minus 2x leaves me the difference of 0, which is actually quite an important exponent. So leave it there, times, as far as the base 3, do you see the 1x and the minus 1x? Guys, keep quiet, cancel. And you're left with 1 plus 1, which is 2. Any base to the exponent of 0, that is 1. And 3 squared is 9. So 1 times 9, your final answer is 9. Now, I spread myself a little bit over, but that is type 2. Right? So I hope you made just a quick note. What you should do, just make a note of the question. Just write down 6 to the x plus 1 dot, which means times 2 to the x minus 1 over 4 to the x dot 3 to the x minus 1, right? Make sure that you know the answer. The answer is 9. And if you can't get it, you speak to me again. I will send it to you. But I want to just revise quickly type 3. And then once I've done type 3, I want to raise the level a little bit on type 3. So everyone watch type 3. Remember, what makes in my, look, the book is not going to say it's a type 1, type 2, type 3. This is something Mrs. Holmboe makes up. But type 3, you will see basically terms. In other words, whether it's in the numerator, you'll get pluses and minuses between the bases. So do you understand that is going to make it the type 3, where we've got to factorize. All right. If I just make one up, if I have 5 to the x minus 1 plus the x 5 minus 5x. Simply calculated. You cannot that 5 that because lesson is a flat bracket. What you've got to do, simplify this. So if you get 5 the x, do you agree you can do 5 times to the minus, because and you tie you. So we're going to break this and that. Then we need to, so 5 to the minus plus to the 1 over to the x minus. I want you to think about to the x. Say that numerator, take out 5 of x is common factor. We're going to dominate. All right? If you take to the x new in the common factor. So the first little term, the x, you have 5. Right, that's in the new out 5. In the G, that 5 once there, 5 squared. And This 5 to the exponent of x will cancel with that 5 to x, but you're left with 1. If there are 2 termies there, you've got to have 2 termies bracket. All right, then you can cancel out the 5 to the exponent of x. Now, you cannot bring that 5 to the minus 1 down and jump the line, change the sign of the exponents because you've got terms. But what you can do in the numerator, that is over a 1. So you can flip the base, so it becomes 1 over 5. And now the negative exponent is positive. Plus 5. And in the denominator, 5 squared, we know is 25 minus 1. Okay, anything to the exponent of 1 is 1. So you've got a fifth plus 5. Should we put the 5 over it goes 1? That is my numerator divided by the denominator. 25 minus 1 is 24. Put that over it goes 1. In the numerator, we're going to LCD it, which you cannot drop. This is not an equation. So 5 divided into 5 goes once. 1 times 1 is 1. 1 divided into 5 goes 5. 5 times 5 is 25. Okay, we can change the divide to times and tip. So if I finish this, 25 plus 1 is 26. It's sitting over 5 times 1 over 24. Okay, now I can cancel definitely 2 into each of these, maybe more, but let's start with 2. So 2 divided into 26 goes 13. Okay, that's prime. It won't go further. 2 goes there, 12. So your final answer, 1 times 13 gives you 13. And in the denominator, 5 times 12 is 60. All right? Now, I just made that one up. But do you see what I'm trying to show you? Step 1, if you get pluses or minuses between the base, factorize. Do you notice that the x was a 1x, a 1x, a 1x, a 1x? So then you just take out a highest common factor. Now I'm using, so now watch what I'm going to do, right? If I use the textbook, and I'm specifically looking at page 5 still, but now I'm looking at exercise 3. I'm still going to say simplify. But a lot of you are not going to know how to do this. Because if I look at number A from exercise 3, it says 2 to the 2x minus 2 to the x over 2 to the x minus 1. Now, guys, you cannot take out a 2 to the x as a common factor. All right? What I want you to do is I want you to, actually you could actually. So, sorry, I'm lying. In this example, there's 2 ways you could do this. All right? There's 2 ways. You see, 2 to the x, it means, 2 to the 2x means 2 to the x times 2 to the x. So yes, in this example, you could take out 2 to the x by division. Then you'd be left with 2 to the x. Do you see same basis, multiply, add the exponent? That would be minus 1 over 2 to the x minus 1, which you know you put in a bracket because it's below a division line. So in that example, we were left with 2 to the x. But I said there's a second way to do this. If you have 2 to the 2x and you have 2 to the 1x, you can let, now just before you say what have I done, let the smaller one be k. So I'm saying let 2 to the 1x be k. Now, if you have 2 to the x times 2 to the x, do you agree that is me saying k times? If I let 2 to the x be k, and k times k would give me k squared. So if I let 2 to the x be k, then 2 to the 2x would be k squared. Now you don't have to use this method, but you might find it easier. So you let the smaller one, you say let 2 to the x be k, then this becomes k squared minus k over k minus 1. Then you can take out your k, leaving you k minus 1. Then the brackets cancel, but you can't end there because remember, who is k? K equals 2 to the x. So do you understand? I don't mind which way you do that, as long as you get answer. Okay? So sometimes you are going to find it is easier to use the K method. All right, let's look at a few more examples. I'm just erasing that out. If I stay with exercise 3, number B said 2 to the 2x over 2 to the x plus 1. Now, do you see this index? An index is a synonym for exponent. This index is 1x, and this index double 2x. So if you get that double index, 1x, 2x, we can use the K method. You don't have to, but I'm going to. Say let 2 to the x be k. Then this is going to be k squared minus 1. And this will be k plus 1. If you still don't understand why this is k squared, remember 2 to the x is k, and I times it by 2 to the x, which is k. You have the same base, write it down, add your exponents, and you'll see that's k times k, which is k squared. So that is why the double index becomes k squared. Now in the numerator, do you see this is the difference of two squares? So I can factorize the numerator. Do you remember one bracket gets a plus, one bracket gets a minus, square root the first term, put it in the front, square root the last term, put it in the back. In the denominator, you got your k plus 1. So that factor cancels out. Now your answer is not k minus 1 because k is 2 to the x. So your final answer will be 2 to the x minus 1. So where you've got this k, replace it with 2 to the single index of 1. Okay, now listen, I'm not going to do a whole lot of those. The probability you won't even get one, all right? We will be using the 2x when it comes especially to the exponential equations. For the rest of the lesson is I'm going to leave simplification, and I'm going to now, for the rest of today and tomorrow, I'm going to look at exponential equations. Now, guys, an exponential equation is when your variable x is in the exponent. Let's actually rather put it there. So, do you see what I'm saying? The x is in the exponent. That makes it exponential. Do you remember in grade 9? I'm going back to grade 9. They would have said, if 2 to the x equals to 8, solve for x. No calculator. Now, you see x is in the exponent, so it's exponential. Your aim here is to get the bases the same. I'll show you why. So break into prime, 2 to the x, 2 is prime. You all agree 8 is 2 to the 3. So the base 2 to the exponent of 3, that is 8. Now we have a very fancy rule with exponential equations. When it's 1, okay, that wasn't funny. Keep the music off. When you get one term on the left side and one term on the right side, if the bases are the same, the rule says you can drop the bases and you can equate the exponent. So I have solved for x. But you can only do that if you have one term. Guys, whoever is doing the music, stop it. It's not considerate for the other people on the group. Now, I will have fun, but I'm getting cross with this grade 11 group. Not all of you, but some of you are still taking this as a joke. Now, I don't think that you must take this as a joke, because I promise you, when school goes back, when you see me, what you talking about? What you talking about? Niggas always want to chase. Haja, I'm going to find out from you later who's playing that music, and that person is going to get reported. It's the third time now, and it's actually not funny at all. So, Haja, I'm going to ask you who that is, and it's not splitting on your friends, because otherwise I'm just going to take over the admin myself. Right. Now that is grade 9. So let's... Are you dumb, stupid, or dumb? Huh? Right, that is the 4th time. You think it's so funny, but all you're thinking about is yourself. All right? So you are having no respect for anyone else on this group but yourself. So if I hear that music one more time, I'm stopping the Zoom lesson immediately, and I'll even contemplate if I'm going to do it tomorrow. If I raise the level a little bit, still grade 9. Let's say I've got 3 to the x equals 1 over 27. This is still grade 9. It's not grade 10 or 11. But you see, 3 to the x is prime. 27, you can jump the line, change the sign of the exponent. So do you see, by putting that up there, it's now over a ghost 1, and the positive 1 exponents become negative 1. But then I can break 27 into 3 to the power of 3, but it still has negative 1 exponent. If you have the exponent raised exponent, you multiply the exponents, and you get 3 times minus 1 is minus 3. Do you notice the bases are the same? One term. So that means that you can drop the bases and equate to exponents. So x equals to -3. Right, the next example, I'm taking it out of the textbook, which means it's kind of grade 11, 10, 11. So in other words, I'm raising the bar to grade 10/11, but I'm keeping with the one term, because that is going to change. We're eventually going to get 2 or 3 or 4 terms. And see if you remember how to do that from last year. And maybe some of it will be brand new to you. If I just turn the textbook, you don't have to follow what I'm doing. But if I just go, sorry, I'm just looking, here we go. So let's say I'm going to go to, if that's 2 terms, let's just see if I've got one. I thought that was a 1 term. Yeah, okay, it's not very hard. I'd say this is grade 10. Really nothing hard. So let's just say I'm going to page 12. Okay, right at the top, number D. So it said 16 to the x dot 2 to the x plus 1 equals the 5th root of 4. Now the most important thing is this is 1 term. Because that 16 base is joined by a times. And that is 1 term. Now, that is when your aim is to break your bases into prime factors. All right, 16 is 2 to the 4, and I'm raising that to the x times. 2 is prime equals. Now, 4 is 2 squared. And this is the 5th root. Now, do you remember I've shown you to take the root, you write your base, and you divide your exponents like that. So whatever the root is becomes the denominator of the fractional exponent. If you look here, 2 multiply to the 4x, and because the bases are the same, I can add the exponent, so plus x plus 1. So I have 4x plus 2x plus 1, same bases, write the base, add the exponents. So now we're going to have 2 to the 5x plus 1 equals 2 to the 2/5. Now, if it's 1 term, same bases, I just equate the exponents. Now, don't panic that there is a fraction. You're just going to say 5x plus 1 equals 2 over 5. If I put everything over 1, my LCD is 5. 1 divided to 5 goes 5. 5 times 5, that's 25x plus 1 divided into 5 goes 5. 5 times 1 is 5. 5 divided into 5, 1 times 2 is 2. The x has an exponent of 1, which makes this a linear equation, which means, like you did in grade 8, keep the variable on the left, take the constants to the right, and then divide through by the coefficient of the x. So x should be minus 3 over 25, which is because if you look at the textbook, you will see I am right. All right, now let's show you what happens if you get a decimal. All right, so you're all watching. If you get a decimal, for example, 0.375 to the exponent x equals to 9/64. You need to get this decimal as a common fraction. Now, your Casio will help you. I'm just trying to see if I can find my Casio. Otherwise, I'll have to do it the long method. One sec. Oh, here it is. You see, in my day, we had to say there were 3 digits, so it's over 3 zeros. There's your 1, 375, and simplify. But you guys have it very easy. You just go 0.375 equals. You see, your Casio gives it to you. You are extremely lucky. 9 is 3 squared. 64 is 8 squared, which means that is 3/8 to the exponent of 2, and that is 3/8 to the exponent of 1. Right, so what's the question? Where's the x? Oh, 1x. This tablet there, the bases are the same. Do you see that? And therefore, you can equate the exponents. All right, guys, we've got 5 minutes. So let me give you your homework. Please do not go further with this section because you will get confused. If you go slowly with this section, you will actually really enjoy it. So what I want you to do, I want you to go to page 12. I want you to go exercise 7, from A to N. A starts with 3x equals to 1. I will remind you, 1 is a very special number because you can make it any base to the 0. So therefore, x is 0. Okay, so I did A. Then you've got to do B, C, D, E, F. They're all relatively easy. And number N, you can think about that one a little bit harder. Okay, so I want you to do that for tomorrow. In the meantime, when I have a chance, I'll see if I can find the teacher's guide. The ones I'm looking at mainly were from exercise 1 and 2 and a little bit of 3 from page 5. Now this book goes in a funny order. So you might find then it goes into thirds or something, and then it comes into something strange, and then it comes back into where I am. So the bit in the middle with the thirds, these guys, I haven't done that yet. So don't do that now. I will teach you how to do that. This textbook does go in a funny order. They've actually brought out a revised edition, which is much better. Okay, so guys, we've got 2 minutes. So I'm just going to give you the quote of the day and then say goodbye. All right, so my quote for today, Thursday the 14th, says, words mean, which means words mean something. So words mean and words point. So sometimes through your words, you can point at a point or at someone. So words are arrows. Arrows stuck in the rough hide of reality. So if it was an arrow stuck in the hide of a buck, that's the skin of the buck. So your words are arrows stuck in the rough hide of reality. Okay, that's quite profound. That was by a writer, Susan Sutton. Anyway, guys, please think about the respect and the music and all that, because as I say, you know, if I, for example, have the coronavirus, I'm not going to go out to the supermarket and spread it to everyone, because that's called inconsiderate. You playing your music, and there's 70 people on the group, and 69 are trying to listen. Do you see the similarity? All right? That is called inconsiderate. But I do want to have fun. I will bring Bob back. I will bring my bell back. I will bring my jokes back. if you guys can prove to me you can behave. Anyway, signing out for today. Bye, guys.